Hello students, in this video we'll discuss inequalities that relate annuities immediate and annuities due together with nominally paid monthly or peathly annuities. So let's let I be the effective annual rate of interest with then we have the following relationship. We have 1 plus I is equal to 1 plus IP over P to the power P. And this is equal to 1 minus D to the negative 1. And this is equal to 1 minus D to any other number K over K to the negative K. So we have this relationship that relates the effective annual interest, I, the effective annual rate of discount. So this is our effective annual rate of discount. And the dk and the IP are the effective nominal rates of interest and nominal rates of discount respectively. And this is true for any value of k and any value of p. Beautiful. Now we automatically get relationships between these things. We know, previously we've proven, we know that I is bigger than IP. And IP are decreasing, and they decrease to a number delta over here. And then that delta is bigger than what happens as these dp increase, so dp, the effective nominal rates of discount, and that's bigger than d. And all of these inequalities follow from the binomial theorem. These follow from the binomial theorem. And binomial theorem with negative exponent or Taylor series. So we get those relationships. And now we recall that A bracket Ni is 1 minus nu to the n over I, and A NIP is equal to 1 minus nu to the n over IP. Now since I is bigger than IP, this denominator over here is bigger than this denominator over here. If you make the denominator bigger, that makes something smaller. So if I have half of a pizza, half is bigger than a millionth of a pizza. So what that tells me is this gives me the first inequality in our string, namely that ANI is what? Is less than this ANIP. This implies that AN is less than ANIP. We know that ANI bar is 1 minus nu to the n over delta. Now delta is what? Delta is smaller than IP. So this number over here is bigger, which means that the continuous annuity has to be bigger still, because you're making the denominator even smaller. That makes the whole thing bigger. So this is less than A bracket NI. Beautiful. And now, how do these relate to discount? Well, I know that A double dot NIP is 1 minus nu to the n over dp. And the dp's are less than delta. So that tells me over here that AN bracket I is less than what? Is less than, this is going to be smaller still, so this is going to be less than A double dot P N I. And finally, D is the smallest of them. So this is going to be the same reason. This is less than A double dot N I. So if I put all of these inequalities together, we get the following result. And this is going to relate all of our annuities over here. So we can relate all of our annuities by the following formula. We know that ANI is the smallest, which is less than the nominal for NEP, which is less than the continuous I, which is less than the nominal discount annuity due, which is less than the overall due annuity. And now let's stop and think about this from the timeline perspective. This will give you $1 at time 0, whereas this gives you $1 at time, it gives you 1 over p at time 1 over p. So it's better to have $1 initially than it is to have $1 at time 1 over p, even if it's 1 over p of $1. And then likewise, this smooths all those dollars out, so you're getting less than what you would get from if you would just have $1 time 1 over p. This is going to pledge to you going to be $1 later on, right? So in other words, that's not going to be as much. And likewise, that's finally the last one where you get $1 at the end of the year. So it makes sort of intuitive sense that this is giving you the $1 straight away, and this is giving you the $1 at the end of the year, and everything in between is a version of giving a fraction of that $1 at some intermediate time in between times 0 and 1. So this string of inequalities is a good one to remember. Always remember that the annuities due are the ones that dominate in terms of the present values. So the present values of annuities due is always greater than the present values of annuity immediate. And so remember that annuities due always dominate in terms of their string of inequalities. Thank you very much.